I will discuss how many volts the IPM installed in the mini split air conditioner circuit board passes through the inverter compressor, which makes the compressor start. Other than this, we will see how many voltages are passing through the low side pins of the IPM through which the compressor is driven. Now, have a look at this circuit board. I have worked on this board. I have changed these components in this circuit board. I have changed almost all the components of the high side. Now let me tell you what had happened with this circuit board. All three capacitors of this circuit board were blown up. After blowing up, these capacitors may have heated. As the cover of this circuit board is badly damaged, it has melted. This circuit board has gone through a very bad situation. I have already fixed this circuit board, and it's turning on. So now we will check that this circuit board, after being powered on, starts the compressor at how many voltages. I have installed these new capacitors in this circuit board. Let me tell you one more thing. The two capacitors I have installed are 660 microfarad, and the voltage capacity of these capacitors is 450 volts. These two capacitors are of the same value, but one of the capacitors, which is this one, I have installed of a different value. The voltage value of this capacitor is the same. The capacitance value of this capacitor is 560 microfarad. These three capacitors are connected in parallel in the circuit board. The capacitance is added in parallel connection. The voltages remain the same across all the capacitors. Now, if you don't have a capacitor of the same value and you installed a capacitor with a capacitance of a higher or lower value than the original capacitor, it will make no such difference. The voltages of the capacitor should be the same, because if you installed the capacitors of different voltages, then the capacitor can blow up quickly. The capacitor with lower voltages can go bad quickly, and then with it, the capacitor with a higher value also has a chance of getting damaged. Other than this, the low side components attached to the low side pins of the IPM, like resistors, etc., which are the safety components, were also damaged badly. You can also see that the feedback capacitors were damaged. A Zener diode was also damaged. I have replaced it with a new one. Other than this, a TLP351 IC is installed, which is an optocoupler. I have replaced it. This optocoupler drives the IGBT. These are all the components which I have replaced in this circuit to repair it. So now let's check whether the voltages through this circuit board are passing correctly to drive the compressor. This is the indoor unit of its outdoor circuit board. I have turned it on with the remote. I have connected all the wires with the outdoor circuit board connector. I am willing to show you what is the situation with this circuit board right now. The communication wires are also attached to its terminal. As soon the electricity will pass through this circuit board, then we will get to know what the situation is going on in the circuit board. Let me tell you one more thing. If I test this circuit board without communication wires from the indoor unit, also, without attaching the compressor connector with the circuit board and the rest of the things, this circuit board seems to be okay. It shows no fault. But right now, I will tell you that there could be such a situation with the circuit board that the high side of the IPM will seem fine, but the problem could be on the low side of the IPM. This is the situation on this circuit board right now. The electricity has not passed yet through this circuit board. I am waiting for it, and as soon as the electricity passes through it, let me show you what is going on with this circuit board. Now have a look that the circuit board has powered on. 315 volts are passing through this pin of the IPM, which is absolutely fine. So now I will check the voltages on its next pin, which is the U pin. 15 volts should be passing through the U pin, but 73 DC volts are passing through this pin. The next pin is also showing 73 volts, and the same 73 volts on the next pin. This means that the high side of the IPM is not fine, because when this circuit board is tested without the communication wires, it shows the voltages fine. However, as soon as it is connected to the communication wires, it creates a problem, which means that any components on the low volts pins of the IPM are short-circuited. The microcontroller could also be short-circuited. The compressor is not starting. No function is working. The pin numbers 5, 6, and 7 on the low side of the IPM are high in. Positive voltages are passing here. Let's check how many voltages. 2.74 volts are passing here. However, it is not working. Now let's check the voltages on the next pin of the low side. 2 volts are passing on the next point as well. Let's see on the last point, 3.3 volts are passing. 2 volts should have been passed through this point as well. The voltages are coming from the microcontroller, but the IPM is not turning on. 15 volts should have been passed before getting started, but 15 volts are not passing. Now, how much voltage should be on the IPM after the compressor starts? I will show you that in the later part of this video. Let me tell you one more thing. When the electricity was passed into the circuit board, I should be checking the voltages quicker. What will happen if the voltages are already passing through these points? This means that the microcontroller is short-circuited. It passes voltages directly without the electricity being passed through the circuit board. But if the voltages are passed after some time, and the microcontroller turns it on after some time, then this means that the microcontroller is fine. This means something is short-circuited over here. Due to this, the circuit is affected. I will have to judge both of these things. And I will have to do it quickly because if I get late in judging it, I will not be able to analyze the problem. Now, I have attached the multimeter probes with the low side point of the IPM before the electricity is passed through the circuit board. This will let me know whether the voltages are passing from this point or not. I will have to wait a little. The electricity has started to pass through the circuit board. 2.7 volts are passing through this point, which is wrong. This means that the microcontroller is short-circuited and the voltages should not have passed here directly. When the circuit board switches on, after some seconds, it turns on its fan first. Then it starts to pass voltages. The frequency could vary. We could not judge that on a multimeter. That will be checked through the oscilloscope. The circuit board has turned the fan on now. And before turning the fan on, it had passed electricity here. This means that the microcontroller of this circuit board is working directly. It has been short-circuited. This means that it has no control over the IPM and the rest of the circuit's control system. Now this circuit board is faulty. I could not make you test the voltages on this circuit board. I have another working circuit board, which is the same as this one. So, let me show how much voltages pass through the IPM towards the compressor on that circuit board. Now, this is another circuit board, which is fine. This circuit board is powered on. Now, if I check the voltages on the low IPM points, no voltages are passing through this low side point. The circuit board's relay has switched on. Now, the voltages have started to pass through this point. You saw the voltages after the relay switched on. 2.4 volts are shown on the multimeter. The compressor analyzer attached to the compressor is working. The compressor has also taken a soft start. If I check the voltages on the rest of the points, the same voltages should be shown. I will be really careful while attaching the probes, because if something goes wrong, it will cause a problem. From here, the circuit board is directly attached to the microcontroller. The voltages pass at this point as well. The same voltages are shown on all 3 points. The compressor is also working. The voltages I showed you on the previous circuit board were directly passing. That is why the microcontroller had no control over that circuit board. I have attached this OK circuit board and made all the wiring connections. Now, let's power it on, and then you will see how much voltage an OK circuit board gives to the compressor to start it and perform the rest of the functions. I have powered on the circuit board. The 2 LED lights are on the circuit board. One light flashes and the other is stable. The circuit board has switched on the fan, but I didn't install the fan connector on the circuit board. It is an AC blower motor. It will make no issue. The analyzer has started to work. All the IGBT in the circuit board are turning on. If we see the voltages on the multimeters, I have attached them on all 3 phases of the circuit board. 143 DC voltages are shown on the multimeter, which are the initial starting voltages. The voltages are almost the same on all the phases, just a difference of 3 to 4 volts on this multimeter. That could be the problem of multimeter accuracy. Let me show you that the compressor is working. You can hear the compressor sound. Right now 140 volts are shown on the multimeter, but as soon the speed of the compressor will increase, the voltages on the multimeter will also increase. Because whatever the frequency is on the low side, the same voltages will be shown on the multimeter. The voltages have increased more and have reached 184 volts. This is the second speed of the compressor now. It will further increase the voltages. After that, the speed of the compressor will be maximum, and it will keep working. See, these are the voltages on the multimeter right now. Have a look at the amperes. The compressor is working on 2.3 amperes because it has no refrigerant inside it. But if the unit had been piped and loaded with the refrigerant, then, the system of this unit would have checked it and passed more voltages to increase the compressor's speed. As there is no load on the compressor, the circuit board cannot understand what to do. I will now test the AC voltages. Let's see whether the inverter compressor voltages can be tested on AC. So you'll find out when we check it out. The compressor and analyzer have started to work. The AC voltages on the multimeter are quite high. Initially, at the start of the compressor, the voltage on DC was 145. On AC, it is showing 160 volts. The voltages on this multimeter are different. These two multimeters show accurate AC voltages. It could have a low accuracy because this is a cheap multimeter. Now, all the multimeters are showing the voltage value differently. This is showing 156 volts. The multimeter on the right shows 164 volts, and this multimeter shows 123 volts. The value of the AC voltages of the air conditioner inverter compressor will be this on the multimeter. Now, as the compressor has speed up, the AC voltages have also increased. 194, 165. This multimeter shows 186 volts. The amperes are the same as those I showed you before. So, the mini split air conditioner compressor U, V, and W phases can be tested on AC voltages. I am tired now, and I run on coffee, so buy it for me on Patreon. Click the link on the screen to visit. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.